Hello. Today we're going to take a look at how to create a custom Labware definition for Opentrons reports. You may notice that when you open the Opentrons app and click on Labware, you will see there are pre-loaded Labware into Opentrons app by default. But what if you don't have a Labware which you're interested in? So how do you create a custom Labware? It's pretty simple, and let me walk you through it. So the first thing I'm going to take a look at is what type of Labware you want to use. In our case, we are going to use for demonstration this thermoscientific Apogee 96 deep well plate. Now here are the prerequisites to basically create a custom Labware. You'll need technical drawings. So let's take a look at this manufacturer. Fisher Scientific is probably providing some documents. Let's find out what they have. Usually this could be a documents panel, or just search on Google for technical drawings for your particular Labware. Okay, now in the document section, we have a data sheet and there is manual, which is technical drawing. Let's click on the technical drawing. Cool, so this is a complete preview of what we exactly need in a Labware, which is basically uh, the whole map of the plate, probably the height, the depth information. So what we are going to do now is, first of all, head on to labware.opentrons.com and go to the left pane and scroll down a bit. You can find out Custom Labware Creator. Let's click on it. Now in the Custom Labware Creator, it's asking you what type of what type of Labware are we creating. So we have a well plate. It's a deep well plate, so it will fall under a well plate category. And let's start creating a Labware. Okay, so now the first question which is asked is, are all of your wells same shape and size? I'll click yes. And then the total footprint. So let's take a look at what the total footprint is. For this particular Labware, the wells are of same shape and size. Um, the total footprint is basically the outermost dimension which is provided over here, which is 127.76. And for the width, it is 85.48. So again, going back, we have the information we need. I'm going to input over here. So it's 127.76 and the width is 85.48. Cool. Now we need the following information, which is the total height. To find out the total height, let's go back to the design, and over here we have the total height of the Labware, which is 24 millimeter. So I'll go in and fill in over here, which is 24 millimeters. The grid. The grid is basically number of rows and number of columns. So this is a 96 well plate. It's 8 rows, which is A to H, and 12 columns, which is about 12. And are all of those are rows and columns evenly spaced? Yes. So 8 rows, 12 columns, all of them are evenly spaced. Cool. Now the next section we are looking at is total maximum volume of each well. So volume over here, it's not really evident from the specs over here on the right hand side. What we are going to take a look at is the title, or we'll go back and reference over here. So it could be written in the specifications right around here, like it's a 1200 microliter plate. It's usually volume metric well. So the information which is provided over here is about 1200 microliters, and I'm just going to add it back to our volume section. Well, now we need to find out what is the well shape and size. So what are we looking at? Over here we are looking at what is the shape. Is it circular or rectangular? So if we go back to the design, it's a bit confusing from this design if it is a square well, because the title says it's a square well plate and there are some circles over here. So now I'm going back to the image and just see what kind of Labware it is. It seems like it's a square well, and I'm just going to click over here, rectangular. Now let's get back to the designs and find out what are the X and Y dimensions of this rectangular well so that we can fill in the information over here. Going back, we can find over here it's given 8.4 millimeters and the Y is also 8.4 millimeters. So let's fill in the information. Now the next thing is, what is the well bottom depth? So we need to find out what is the bottom shape. I guess this one is either U or V, but let's find it from the design itself. So in the design, you see the construction is basically a U bottom. Now we'll just confirm if it is a U bottom if there is confusion by going back to the thermoscientific description, and they specifically mention over here these U bottom 1.2 mil storage plates. So this is a U bottom. This is the hard surface we're looking at. I'm going to hit U and the depth. Now to find out the depth is basically the height minus the bottom thickness, which is 24 minus 3. 21 millimeters is what we're going to add over here. And then well spacing. So the well spacing information is how much is well to well distance. This is pretty standard for a 96 well plate, which is 9 millimeters, but let's try to find out. Right over here, they have given the center to center distance of the well, which is 9 millimeters. And even for the Y, it is 9 millimeters. So I'm just going to input the information over here. This is 9 millimeter for X spacing, and for Y, it is 9 millimeters. Now, the final thing which we are interested in is finding out the center of the well to the Labware footprint. So basically, it's given over here. And we need to find out the X offset and the Y offset. That can be found out really going back to our design. Right from here, this is the edge or the boundary of the Labware to the center of the first well, which is 14.38. And again, in the Y direction, it is 11.24. So I'm going to fill in the information over here, which is 14.38 and 11.24. The final thing we are interested in understanding stacking offset. So this is a dipole plate, usually used for extractions as well. So you can create this compatible with the magnetic module block, a magnetic block. And if there is any spacing required from the block to the top of the Labware, you can input over here, which is going to be the total height. In this case, I'm not 100% sure, so I'm just going to skip this part. Now, we have a complete preview of what our plate looks like, which is very similar to what is seen over here. And then we would like to put the information. So the brand is Thermoscientific AppGene. I'm just going to copy this as it is. In the manufacturer catalog number, I guess it's this one. This is an optional field, so don't worry about it. And now there is a display name which is default, and there is an API load name, which is, again, you can change these names. So for example, I can put this as AppGene well play. And if you want to add, you can add AppGene well play 96 words. And you can add AppGene 96 well 1200 microliter over here. I'll just click on export this file, and this will give us an export. Now, let's try to take a look at how we can use this in the protocol designer. So I'm going back to Opentrons protocol designer. So designer, now we have a refreshed look of the protocol designer. So if you look at the protocol steps, you can add this plate on any slot. So let's click edit slot and add hardware, Labware. So let's click on add a hardware or Labware. So we already have a module, but I'm not interested in adding a hardware. I'm interested in adding a Labware. I'm going to scroll down, upload a custom Labware. And this is the custom Labware which is available. So I'm going to click on AppGene well plate, which is available right over here. Yeah. Now say if you want to make any changes to the custom Labware, we can go back to the custom Labware creator. And instead of using the same Labware, we can drag and drop the Labware over here, which we just created. AppGene well plate right over here. The dimensions will be pulled out. And if I want to make, for example, a change in the depth, maybe 20 or something, if you find after calibration that it was incorrect, you can make the changes and you can again export the file.